So in the previous class, we learned something about fundamental quantities and derived quantities. Somehow we practice to calculate fundamental quantities involved in derived quantities. And in little, so we also learn to express very big and small number in the power of 10, which we say scientific notation. In today's class, so we will try to define three fundamental units according to our syllabus curriculum. So we must define meaning of three fundamental units. They are 1 standard meter, 1 kilogram, and 1 second. So the students of class 9 must be able to define these three fundamental units. What is 1 standard meter? What is 1 kilogram? And what is 1 second? You know, so we have the idea of 7 fundamental quantities with their respective units. Among them, so we are discussing only three fundamental quantities and their units. So let's start class 9. So are you all ready? So you can have your notes, copy, and pen. And if even if you have a book, so you can go through the book. Fundamental quantities and their units. Let me show you the slide. So which I showed in the previous class. I hope all students of class 9 now can say the name of 7 fundamental quantities with their units. We know the units of fundamental quantities are called fundamental units. Let me go to another slide. So now this is the beginning of today's class. So the first fundamental quantity and its unit. So we are going to read today is length. So in the previous class, we came to know what is meant by length. Simply, length is defined as the distance between any 2 points. Since the quantity length does not depend on other quantity, it is called a fundamental quantity. And you know, dear friends, in SI system, the length quantity is expressed in the unit called meter. Means the SI unit of length is meter. You can see the picture of measuring tape. So measuring tape is one of the device so which we use to measure the length of an object. Let's know the meaning or definition of 1 standard meter. What is meant by 1 meter? It can be defined as the length of the path traveled by light in vacuum during a time interval of 1 upon 29, 97, 92, and 458 of a second. Okay. Let me simplify this meaning or definition. Everybody knows the velocity of light in a vacuum. If I ask you to say the velocity of light in a vacuum, Everybody can give the answer. Velocity of light in vacuum is 3 into 10 to the power 8 meter per second. Means in 1 second, light can travel a distance of 3 into 10 to the power 8 meter. Okay. In fact, the exact value of the distance traveled by a light in a vacuum in 1 second is, okay, it is 29, 97, 92, 458. Or I can say 29 crore 97 lakh 92,458 meter in 1 second. Light travels so fast that in 1 second it can travel a distance of 29 crore 97 lakh 92,458 meter. We round up this value, okay, in 3 into 10 power 8 meter. So later on, so I will show by writing in whiteboard. Just now, just observe the definitions of 1 meter. I hope all the students understand easily. So means in 1 second, if light travels very long or large distance, which is equal to 29 crore 97 lakh 92,458 meter, means in very less time, very small time, the time is equal to 1 upon 29 crore 97 lakh 92,458 of a second. Then how much distance a light can travel? That is equal to 1 meter. Very small time. So 1 upon 29 crore 97 lakh 92,458 of a second means very small time. In such a small time, so how much distance a light covers? The distance is equal to 1 meter. You got it? So likewise, now let me step to another fundamental quantity, a second fundamental quantity, that is mass. And mass is the total quantity of a matter contained in a body. It is determined by the number or the amount of molecules of a substance. The mass is a fundamental quantity. In SI system, this quantity is measured in unit called kilogram. Means the SI unit of mass is kilogram. It's very easy. The SI unit of length is meter and the SI unit of mass is kilogram. And the device shown in the picture is beam balance, so which help us to measure the mass of a substance. And how do we define 1 kilogram? One standard kilogram is defined as the mass of a platinum iridium cylinder having equal diameter and height at 0 degrees Celsius at the International Bureau of Weights and Measures. Means there is one cylinder, so which is made of an alloy. That is, the alloy is the composition of two metals. One is platinum and another is iridium. Alloy made of platinum and iridium that is converted into the shape of cylinder. Such cylinder having equal diameter and height. Let me tell you the platinum iridium cylinder, okay, which mass shows equal to 1 kilogram. Its diameter or height is equal to 39 millimeter, 39 mm. Very small cylinder. That platinum iridium cylinder was kept at the place called International Bureau of Weights and Measures. This place is situated in France. In 1961 AD, Okay, that the system of units were established at the time. So one of the unit is established given to the quantity called mass, this kilogram. And how did scientists define one standard kilogram? They defined one standard kilogram on the basis of a cylinder that was made up of platinum and iridium alloy. Let me show that the picture of the cylinder. You can see on your screen the cylinder that is enclosed inside that jar. The same cylinder at the left is shown, which is open. And how high, how big the cylinder is it is just 39 millimeter. Height is also 39 millimeter mm, 39 mm, and its diameter is also 39 mm. In the picture, it does not look like that because I elongate the pictures while adjusting the slide. Otherwise, both the diameter, okay, of the circular face and the height are equal, which is equal to 39 millimeter. And the mass of this cylinder is taken equal to 1 kilogram. Now we have another slide, class 9. Hope you are listening to me. And even you can see your screen that another quantity, third quantity, so which we are learning today is time. So the interval between any two events is called time. And how do we measure the time? We have a device to see the time of current, time. The device is obviously called watch or clock, and we can express the quantity time in different units. Like we can say hour, minute, day, year, week, even century and decade. But let me tell you that the SI unit of time is second. So till now, the students of class 9 are able to know the three fundamental quantities with their units. The SI unit of length is meter, the SI unit of mass is kilogram, and the SI unit of time is second. Now let us define 1 second time. So before we go to the definition of 1 second time, let me say something about a cesium atom. This is an element. It is just like hydrogen, oxygens. We know elements. So one of the element is cesium. Atomic number of cesium is 55, but atomic mass is 133. When we take an atom of cesium, okay, 133, then if we make it vibrate, if we bring that atom into motion, so it vibrates so fast. And when we find or when we record the vibration of cesium atom, that is equal to 91, 92, 63, 17, 70, is equal to 9 billion 192 million 631,770 time vibration. So when the cesium 133 atom completes its vibration, that is equal to 9 billion 192 million 631,770. The time interval is equal to 1 second. Means you understand that cesium 133 atom vibrates so fast. It can make a large number of vibration very short time. Even we do not notice very few seconds. 1 second we do not notice. But in such interval of time, the cesium atom makes so much vibrations, many vibrations that equal to very large number. So 1 second is defined at the time interval of 9 billion 192 million 631,770 periods of specified energy change in the cesium 130 atom. This way, we can define 1 second time. Now, let me connect today's class in another topic. This is prepared on the basis of our syllabus. Dear students, once we know what is time and what units do we use to express time, and what is the name of device that we use to find or to calculate the time, we also should know the different types of devices that we use to measure time in different places. So we have different time measuring devices. Number one is mechanical watch. So different types of watches. The first one is mechanical watch, and the second is quartz watch. Next we have is atomic watch. So let me go to the first one, mechanical watch. So you can see the pictures, and in short, let us know how does a mechanical watch work. So it works on the basis of oscillation of a simple pendulum. The simple pendulum is fastened inside it. So when energy is supplied to it, it comes into motion. And the motion, or also called oscillation of the simple pendulum, helps to calculate or record the time in that watch. Since it has a pendulum inside it, it is also called a pendulum watch. And among the watches, pendulum clock, or let's say mechanical watch, is less accurate. The time fluctuates in a day. Okay? And the watches which are more accurate than this mechanical watch are quartz watch and atomic watch. Among the three watches, atomic watch is the most accurate watch. So it can even record or calculate or show very small and very micro time. The first watch I have shown to you is mechanical watch. Mechanical watch is the watch which works on the basis of oscillation of a simple pendulum. So everybody can say the name of watch, so which works on the oscillation of pendulum. It is mechanical watch, or also called a pendulum watch. Next, number second type watch, we have quartz watch. Inside it, a very small crystal of glass, which is also called quartz crystal, is kept inside it. And when the energy is supplied to quartz crystal, it also vibrates and it makes that needle move. So which shows or which determines the time of a specified place or a specified time. Means, so how does a quartz watch work? It works due to the vibration of quartz crystal. In a mechanical watch, what is inside that? Pendulum. So the oscillation of pendulum shows the time in mechanical watch. In quartz watch, what is inside it? Obviously, it is quartz crystal, and the movement of that quartz crystals helps to show the time by quartz watch. And in further, it is more accurate than the mechanical watch. That means it shows less error. It fluctuates less time. Next, we have last watch is obviously atomic watch. And how did we define 1 second time? So 1 second time is recorded by the vibration of cesium atom, cesium 133 atom. So if we have and watch that has cesium 133 atom, and the vibrations of that atom, so okay, keeps the record of time. So the watch is obviously called atomic watch. So atomic watch works due to the emission of radiation by cesium 133 atom. Cesium 133 means it is an isotope of cesium atom. And 133 shows atomic mass of that atom. Cs is the symbol of cesium, and 133 is the atomic mass. So one form of cesium atom so emits radiation, so which moves that okay the parts of the clock and shows the time. And among the watches, this atom shows the most accurate time. So today's class, so we learned three fundamental quantities and their units along with their definition. I believe all students of class 9 now can say or they have understood what is one standard meter, what is one standard kilogram, and what is 1 second time. In addition, they also came to know the three type of watches. They are mechanical watch, quartz watch, and atomic watch. And let me conclude today's class by connecting the future class with the very short, that is a measurement of length and mass. We say the SI unit of length is meter, and even we say the SI unit of mass is kilogram. But what we all know is there are other units of length and mass as well, because we have different units according to the size and quantity of substance. So if we have to measure the length of big object, we use bigger units. And if we express the length of small objects, we use smaller units. Thus, I want to show you the sub multiple and multiple of meter. Here you can see on your screen some multiples and some sub multiples of meter. You can see decameter, which is abbreviated by DAM, hectometer, HM, and kilometer, KM. They are multiples of meter. And if you go above, that is mm stands for millimeter, cm for centimeter, dm for decimeter. They are the sub multiples of meter. Millimeter, centimeter, decimeter are smaller units than the meter, and decameter, hectometer, and kilometer are the bigger units of meter. Smaller units are called submultiples, and bigger units are called multiples. So you can observe the relation between them. So if you have to know how many millimeters are there in 1 centimeter, so you can see there. So 1 centimeter is equal to 10 millimeter. That means 10 millimeter is equal to 1 centimeter. So you can take the screenshot of this slide. Okay, in next class we'll learn how to convert units of the same quantity, bigger to smaller and smaller to bigger. For that we have to know the relation between meter and centimeter, relation between meter and kilometer. And being the students of class 9, everybody knows. So how many meters are there in 1 kilometer? Obviously, okay, there are 1,000 meters. So 1 kilometer is equal to 1,000 meter. And similarly, we can also see the multiple and submultiple of gram. Decigram, centigram, milligram are the submultiples of gram. And you can see decagram, hectogram, and kilogram. They are the multiples of gram. So how many grams are there in 1 kilogram? Yes, 1,000 grams. So 1 kilogram is equal to 1,000. And 1,000 can also be said as 10 to the power 3 in scientific notation. So 10 mg equal 1 centigram, and 10 centigram makes 1 decigram, and 10 milligram. Please know the relations among the units in the science. So next class we will practice to convert from one unit to another. Now let me come back. This much for today. Thank you so much. So I hope you have understood a little about today's topic. So if you have any comments, if you would like to say something about today's topic that we discussed, you can raise a hand and speak, please. Yeah, Kare, did you understand or not? Sushant?
Yes, sir, ma'am. That
yearly.
one DAG, what it stands for?
That is the decagram.
Deca.
DG only decigram. Deca. DCA deca. Okay, DAM is decameter and DAG is decagram. So they are the bigger units, okay, than the meter and gram like that, multiples. HM stands for hecto. Okay,
Excuse me, sir.
just raising your hands. Azur,
Sir, what means that isotopes?
isotopes, they are the different form of atoms. So having the same atomic number but different atomic masses. So let me tell the isotope of hydrogen. So hydrogen atom can have three isotopes. So when an hydrogen atom has only atom mass 1, then it is called protium. And when hydrogen atom has atom mass 2, that is called deuterium. And when hydrogen atom has 3 atomic mass, that is called tritium. So sometime in some elements or some atoms can exist in different forms with differing atomic mass but same atomic number, and they are called isotopes. Hydrogen, then carbon, okay, this kind of atoms, they can exist in the form of isotopes. They have the same atomic number. Hydrogen has atomic number 1. If it has atomic mass 1, that isotope is called protium. Hydrogen has atomic number 1. If it had atomic mass 2, that is called deuterium. Protium and deuterium are the two isotopes of hydrogen. There is another isotope also that is called tritium. You know that the atomic number is equal to the number of proton, and the atomic mass that can be calculated by the sum of proton and neutron like that. So number of proton in an atom remains stable, but sometimes the number of neutron can vary. So in case of hydrogen, if number of neutron is 0, atom mass is 1. And if the number of neutron becomes 1, then atom mass becomes 2. And if the number of neutron becomes 3, the atomic mass becomes, okay, 3 like that. Number of neutron becomes 2, atom mass 3. Number of neutron 1, atom mass 2. Then number of neutron 0, atom mass 1. So atomic mass 1, atomic mass 2, and atomic mass 3. These are different forms of same atom, and these are called isotopes. So isotope is, okay, the atom having same atomic number but different atomic masses. And cesium 133 is one form of cesium atom, okay, which is kept, to make the vibrations a very large number that determines 1 second time. So class 9, always remember please, to define 1 meter. So we take the reference of light, velocity of light in vacuum. Okay, so how much distance is covered by light in very small time. The difference of velocity of light, that is called one, that is second time, and that is 1 standard meter. And when we define 1 standard kilogram, we take the reference of cylinder that is made of platinum iridium, and taking the reference of, that is cesium atom, then we can define the 1 second time. Yes, I think so you understood well. Thank you,
Sir,
class 9. Thank you
people
so
is
much.
asking question in chat.
Yeah. I'll keep those questions in record. Then I'll write the answer in comment section or in your Google Classroom. So if you do have any questions, so later on also you can discuss. Right now, I hope you understood what we discussed today. अब क्वेसनमा के सोध्यो भने डिफाइन 1 मिटर, डिफाइन 1 किलोग्राम, डिफाइन 1 सेकेन्ड भन्यो भने अब कसरी एन्सर लेख्न सकिन्छ भन्ने कुराहरू जस माइन्डमा बेसी शब्द बस्यो होला नि। आज हामीले डिस्कस गरेको कुराहरू फन्डामेन्टल युनिट्स नै हुन्। थ्याङ्क यू क्लास 9। अब नेक्स्ट टपिक हाम्रो हुन्छ त्यो कन्भर्सन अफ युनिट्स। कन्भर्सन अफ युनिट्स जस्तै विल लर्न टु कन्भर्ट किलोमिटर इन्टु मिटर, सेन्टिमिटर, एन्ड विल लर्न टु कन्भर्ट क्विन्टल इन्टु किलोग्राम। हामी त्यो कुरा सिक्छौँ है अर्को क्लासमा चाहिँ। जस्तै अब कार्यको टर्न है त, त्यहाँ यो त हामीले क्लास 8मा पनि अलिकति पढेको थियौँ होइन, यो रिभिजन जस्तै भयो। बुझिन्छ कि बुझिँदैन कार्य? ओके ल,
बुझिन्छ
बुझिन्छ है।
सर
तिमीले
अस्सिलेसनको
बुक्स छ?
मिनिङ के हो
हजुर,
अस्सिलेसनको मिनिङ के हो
अस्सिलेसन भनेको मोसन हो। जस्तै हामीले भाइब्रेटरी मोसन, रोटेटरी मोसन भनेर अस्सिलेटरी मोसन भन्थ्यौ नि, तर टु एन्ड फोर यता र उता हल्लियो भने, छिटो छिटो मुभ गऱ्यो भने त्यसलाई अस्सिलेटरी मोसन भनिन्छ। जस्तै तिमीले दसैँमा पिङ खेल्दा पिङ चल्छ नि अगाडि पछाडि है, तिमीले ठुलो ठुलो घडीहरू देखाएको छ नि, पेन्डुलम भएको घडीहरू, त्यो दायाँ बायाँ चल्छ नि, त्यसरी पिरियडिक जुन मोसन छ, टु एन्ड फ्रो मोसन, लेफ्ट राइट जुन मुभमेन्ट छ त्यसलाई चाहिँ अस्सिलेसन भनिन्छ।